we're now going to talk about externalities and public goods. I'm going to quickly recap something that you guys may have forgotten from your micro, and then I'm going to extend that to the environment. So that is where we are, and we're now properly in week 2. I'm going to start talking about static efficiency and optimality. So, Pareto argued that a situation is Pareto superior to another situation if nobody is worse off and at least one person is better off. This essentially goes back to Aristotle, who you see here, in which he argued that a trade in which both parties engage voluntarily, knowingly, can only be mutually advantageous, otherwise either one of the two parties would walk away. If we put these two insights together, then trade is Pareto improving. Pareto, now you see Pareto here, also introduced the notion of Pareto optimality. And this is typically in economics referred to as efficiency. That's of course a very silly thing to do of us economists. We tend to give sort of like common names to things that mean very, very different things to everybody else. If you talk to anybody other than an economist about efficiency, they think you talk about something else entirely. But economics, we call this efficiency. And essentially this is the situation in which there is no Pareto improvement possible. That is, we're in a situation where there is no trade that would make somebody better off without making somebody worse off. It's an optimum that immediately implies that you can't be more efficient or less efficient, right? Because it's an optimum. You're either efficient or you're not. And again, going back to the colloquial use of the word, in the colloquial use of the word, you can be more or less efficient. But if you're writing an economics exam and you say, well, this is more efficient than something else, then essentially you're demonstrating that you did not pay attention to micro, right? That is essentially the signal that you're giving. I don't know what the word efficient means if I'm writing an economics exam, and that's a bad signal you want to give, right? So it is efficient or not more efficient. And of course we know from the first welfare theorem that if we have a market without imperfections, then the equilibrium of that market is a Pareto optimum, right? This is the first welfare theorem. We can make this more precise. Let's look at a very simple economy. We have two people, A and B. We have two goods, X and Y, and those two goods, X and Y, are made with two inputs, L and K. So the utility of person A is a function of what he consumes of X and Y. Similarly for the utility of person B, that is a function of what C consumes of X and Y. And then Y is made with inputs K and L, and the same is true for X. As a matter of notation, marginal utility, so the first partial derivative of utility of a person to one of the arguments of the utility function, one of the consumer goods, so that's du dx, in this case is denoted by a subscript for what is at the first partial derivative 2, and the same is true for marginal productivity. This essentially says dy dl, right? So this is if you use a little bit more labor in the production of y, how much does the production of y go up? And that we denote again with a subscript the marginal product of y to L. Right, so that is just notation. Now, efficiency has 3 subconditions. Pareto optimality has 3 subconditions. The first is efficiency in consumption. And efficiency in consumption means that the ratio of the first partial derivatives, the ratio of the marginal utilities to goods X and Y of consumer A should equal that of consumer B. and this is known as the marginal rate of substitution. This was a term coined in the 1870s. It doesn't make any sense to me to call this the marginal rate of substitution, but this is how it's known. I'm not a native speaker. It doesn't make any sense why you would call this a marginal rate of substitution. But that's what we call it in English. So the ratio of the partial derivatives to the two consumer goods should be the same. If not, then we can make a mutually advantageous trade. So let's assume that for consumer A, the marginal utility of good X is 5 times that the marginal utility of good Y. And for consumer B, it's the other way around. The marginal utility of good X is 1/5 of the marginal utility of good Y. So we can then propose a trade, right? We can A gives up 1 Y and get 1 X in return, essentially a barter. And of course, the response is that B gets 1 X more and gets 1 Y less. So if A gets 1 additional Y, he gains 5, but he loses an X, so he loses 1. So that is a gain of 4. C loses 1 Y, that is a loss of 1, but she gains 1 X, that's a gain of 5. So C also has a positive surplus, right? Both gain 4 as a result of this bargain, right? So this is a Pareto improvement. If these ratios of the marginal utilities are equal, then you cannot do this sort of stuff. Then whatever you give up, you get something worse in return, or you get the same in return, right? So this we call efficiency in consumption, and it's one of the 3 conditions for for efficiency. And the counterfactual here shows this. The second condition for efficiency is efficiency in production, which says that the marginal product of making good X, marginal product of putting in more labor relative to putting in more capital, should be equal to the same ratio for the production of good Y. Right? And this we call the marginal rate of transformation, again for historic reasons rather than for reasons of understanding. Again, if this condition is not met, then what you could do is shift labor from the production of X to the production of Y, and in return shift capital from the production of Y to the production of X, so that you make more of both, right? And then because of the rules of non-satiation in utility functions, if you produce more of everything, you are better off, right? So again, this is a condition that has to be met. And then the third subcondition for efficiency is efficiency in the product mix, or efficiency or cross efficiency, or sometimes X efficiency. And that says that for, in this case, consumer B, the ratio of marginal utilities of good X to good Y should be equal to the ratio of ratio of the marginal productivity in capital to goods Y and X. And the Y and the X switch position on the two sides of the equation, because essentially on the left-hand side of the equation this is a benefit, and on the right-hand side of the equation it's an opportunity cost, right? That is why one is a benefit, the other is a cost, and that is why the ratios flip. Essentially what this says is the marginal utility ratio equals the marginal production cost ratio, or the marginal rate of substitution equals the marginal rate of transformation. of course, by the first rule, we have that this thing equals this thing, and by the second rule, and by the first rule, we have that this thing equals this thing, right? If this condition is not met, then you can rearrange the allocation of labor and capital, L and K, not so that you make more of both, but so that everybody gets happier. That utility goes up for both consumers, right? So these are the three conditions in a barter economy for efficiency. Now, I said last week, and I'll say it again, this does not mean Pareto optimality does not mean optimal, right? Because of the second welfare theorem, we can redistribute the initial allocation of goods, of endowments in the economy, and get to another Pareto optimum. And if we want to get to a thing that we would consider optimal, we would need to impose a second condition, namely that the marginal welfare of these allocations, the ratio of marginal welfares of these two allocations, equals the actual allocation, right? And of course, in order to get there, we need to redistribute income. Now, this is in a barter economy. We can do the same thing in a monetized economy, where instead of saying that the marginal rate of substitution, the ratio of the marginal utilities of a good, of the two goods, should not be equal to that for the other consumer, but actually should be equal to the price ratio of the two things, right? That should hold for both consumers, both economic agents, and if they face the same relative price, which they would in a well-functioning market. If I go to the supermarket, I pay the same as when you go to the supermarket, right? If you buy the same things, right? In a well-functioning market, these price ratios are the same for the consumers, and we meet the condition of consumption efficiency, right? Again, if this ratio does not hold, if the ratio of marginal utilities is 1 to 5, the price ratio is 5 to 1, and then what you could do is sell one of your X's. That will give you 5, and that means you can buy 5 Y's. Your utility loss from having one less X is -1. The utility gain of buying 5 Y's is not 5, but it's 5 times 5, so you gain 24, right? In this particular example. So this ratio, these ratios must equal each other. If not, you can just trade your way to a happier life, right? The market economy, production efficiency, same thing. The ratio of marginal productivities, marginal rate of transformation, should equal the price ratio, not of the outputs, but of the inputs, right? So the price of labor relative to the price of capital should equal the marginal productivity of labor to the marginal productivity of capital. Again, this holds for every individual producer, but in a well-functioning market, they would face the same relative price, and you get to product efficiency. If you are in a situation where the marginal cost equals the price, the marginal cost of making product X equals the price of X, that is, we have perfect competition on the supply side, then the product mix efficiency also holds in a market economy, much as it does in a barter economy. So, that is all stuff you recall from your micro, right? Hopefully. Not go back to whoever taught that. Or Varian or somebody like that. Now, the market is efficient if and only if If I write if with double F, that doesn't mean that I can't spell. If with double F means if and only if. Markets exist for all goods and services. That is, property rights are fully assigned. There is not some piece out there that nobody owns or nobody really owns. If all goods and services are private, we'll get back to that. And if there's no externalities. And I'll get back to that. And essentially, this condition can either manifest itself as goods and services not being private or externalities not existing, right? That really property rights would solve both of these things, which we'll talk about in week 8, I think, maybe week 9, maybe week 7. We'll get back to property rights. Of course, another condition is that markets are fully competitive. If the supply side is not fully competitive, then this particular condition doesn't hold, right? Then there's markups in market power in the supply side of the economy, and that means that that condition doesn't hold, and therefore product mix efficiency doesn't hold. And another thing that you need to assume is, of course, that people in the economy, the agents in the economy, behave as if I assume they behaved, right? That is, they want to maximize their utility. They're rational, but they also know a lot. If your ratio of marginal utilities is equal, must be equal to the price, you can only have that if you know the ratio of marginal prices, right? If you know, sorry, not the ratio of marginal prices, if you know your relative prices, right? If you don't know what is going on, then you can't make decisions like this. Similarly, an assumption that is not here, sort of trade is costless, right? If there's a better deal on a product in Bristol, you can just fly to Bristol and get it without any loss in time or any loss in money, right? That is another assumption that underlies all this. Now, why do I say this? We're here not to recap micro, but we're in an environmental economics class. All sorts of environmental stuff immediately violates these things, right? There's many things we care about, natural resources that are not bought and sold on the market. Wilderness isn't owned, clean air you don't pay for, you just have it or you don't, right? It's not something you can buy in the supermarket. Property rights are not assigned. Many resources, the climate, the open ocean are public goods. I'll get to the definition later. Or open access, like fisheries on the ocean. Other resources are traded on imperfect market, lands, minerals, energy. None of these markets, you would say, remotely approximates what you would consider a perfect market, because this concentration of production, this concentration of mining and so on and so forth, that creates sort of frictions in the market through market power, through natural monopolies, and so on and so forth, through lumpiness of investment. The conditions simply fall apart when you're talking about the environment and natural resources. And then, of course, we have externalities as well, and that's what I'm going to start with, and then I'm going to return to the public goods towards the end. So, an externality is the unintended, uncompensated impact of an economic activity on a third party. That is the definition that I use. That is the definition that I think is the best definition of an externality. In the book, as you may have seen, there is a long discussion of all the alternative definitions of externalities that are in the literature. Subtly different, sometimes very different. But this is, I think, the best, most succinct, and the most complete definition. Externality is also called an external effect, an external cost, an external diseconomy, those are all the same things. So if you come across those words, that means the same thing. External effects may be positive or negative. They can come, it's an economic activity, they come about from consumption or production or transport or something like that. It is, those things are all possible. Now, why do I say unintended, right? Why does that word need to be there? So we make, we burn coal to make electricity. So the intent of burning coal is to have electricity. The intent of burning coal is not to emit carbon dioxide and sulfur dioxide into the atmosphere. That is not why we burn coal. We burn coal to make electricity, right? Similarly, we have bees to make honey. We don't have bees to pollinate plants, or at least that's how it used to be, right? So that is the intent of the beekeeper. Honey, not pollinate the neighbor's flowers, right? So that is why we have this word unintended there. If this was your aim, then this is the economic activity itself, right? There is in the older literature a discussion about pecuniary externalities, but they are not the externalities we're talking about. So if on Wednesday Mo Salah scores against Everton, that is his intent, right? It causes grief to Everton and its fans, but they are a party to this game, right? So it's not a third party. But if Mo Salah scores, it also causes grief to Arsenal, right? Who are not on the pitch, but they're nevertheless affected by this goal that he scored. That is not an externality, because it was his intention, usually, to score, right? So intention is important. If an externality is compensated, that is, you have to pay a tax on your emissions, or you get a subsidy for avoiding emissions, or if it's a positive externality, you get paid to bring your bees to the orchard, right? It's actually a pretty lucrative market nowadays. Then it is an economic transaction, right? It doesn't happen outside the market, and it is no longer an externality because you're being paid for your services, or you pay for abusing the situation, right? So intention and compensation have to be part of the definition of an externality. This third party thing also has to be there, because there's also such things as internalities. That is, if you're doing something stupid to yourself, like get addicted to gambling or to alcohol or something like that, that we call an internality. That is, if you do something stupid and you can't stop yourself from keeping on doing it, right? That is not an externality, because the damage is caused not to a third party but to yourself. We call that an internality. If you want to know about internality, George McCarran teaches behavioral economics, I think next term. Right, so those three elements have to be there: unintended, uncompensated, on a third party who is not part of the transaction, has no say over the economic activity. Now, what does this do to efficiency? So the condition for production efficiency is that the marginal rate of transformation, the ratio of the marginal production costs, must equal the price ratio, right, of these things. Now I replace the P here with an S because what matters is that it's the true price, not necessarily the market price, the true price if this price, the social price, what it really costs to use labor, what it really costs to use capital, if that consists of the market price, this is the wage, this is the interest, plus some sort of externality of using labor or using capital, then this is what we want, but the market doesn't see these things, right? The market doesn't see the external costs of using labor, let's call it the external benefits of using labor, or the external costs of using capital. It only sees the market price. So the market will do this, a social planner would do this, right? And as soon as your E's are non-zero, it doesn't matter whether they're positive or negative, you violate production efficiency. So let's make this a little bit more concrete. And I'm going to use very silly example. I'm still going to make product X a product Y, but I'm now going to assume that one is made with labor only and the other is made with capital only. So for the production of good Y, we only use labor. The profit is how much we make times what we sell it for, right? This is the price, minus our production cost, that is the amount of labor that we use, minus the price of labor, that is the wage. For the production of good X, we only use capital. What we get is how much we make times the price of what we sell it for, minus the amount of capital we use times the price of capital, right? So it's simpler in the sense that the K has dropped out there, the L has dropped out there, but we introduce an externality. That is, if we're making product Y, then that affects the production of X, but it does so outside the market. It does so as an externality. Now, it's a silly example. The reason I do it like this is to just simplify the model as much as we can so that the math stays simple. The way to think about it is that the workers of factory Y cause congestion that hinders the robot cars of company X, right? That is how you would sort of like see this as a real example. Obviously, reality is much more complicated than this, but the math is simpler like this. So, company Y wants to maximize its profit, set its first partial derivative to 0, so that it is Py, marginal product of Y, minus PL must equal 0. Company X does the same thing, Px times xk minus Pk must be 0. We can rework that and find this particular relationship, right? Now that is if they separately maximize their profits. Now what would you do if we maximize their joint profits? They're merged, or we're maximizing social welfare. Then we add the two revenue functions, and we also add the two cost functions. We take the first partial derivative of the joint product to capital. When we make the decision about how much capital to use, we get the price of capital times what we produce. Yes, at the margin, and this is the cost of capital, must be equal 0. This condition is the same as we had previously, right? Nothing has changed. If we do that now, do the same for the joint profits to L, we get this expression here that we had before, the price of Y and the marginal production of Y. We had the price of labor here, but now this term pops up as well, which says the retail price of good X times how the production of X is affected by the environmental problem, the congestion in this case, and how much congestion is caused by this. So this is how much production is affected by congestion, and this is how much congestion is caused by the use of labor in the production of good Y, right? Yeah. So the price of good X is as it was. The price of good Y used to be this, and now we have an additional term added to it, right? Which essentially is how much trouble do you cause, how much does your trouble affect production, and then this is the value of that production, right? Let's go back to a decentralized, where the two companies are separate and make their own decisions, but we introduce a tax in the cost function of the production of Y. Right, just for fun, just to see what happens. So we have this tax here, the government steps in. Nothing has changed on the side of X, so this condition stays the same. Things have changed in the production of Y. Now for every unit of labor that you use, you need to pay a tax, tau. So we need not just to subtract the market rates, but also the tax. And that, of course, means that the price for which Y sells now becomes this thing here, where it used to be this. Now we have this. Which, of course, immediately implies, if you go back to the joint optimization, we found this term here. So if it's a plus tau here, and it's a minus 1 here. So if we set tau equal to the negative of the externality, then the two outcomes are the same, right? Yeah, everybody still with me? This thing we call the Pigou tax. So it's a tax on an externality that exactly equals how much trouble you cause, what that does to production, and the value of that, right? This is the Pigou tax. Now the Pigou tax is named after Alfred, pretty sure, Pigou. And I'll show you his definition in a sec. And I dropped a minus sign here. This is unfair. Pigou was the first to introduce a tax like this, but he wasn't thinking about externalities at all. Really, the Pigou tax that I introduced was thought up by this guy here, Francis Bator. But everybody calls it the Pigou tax for reasons that I don't have time to take you into, and you probably find boring as well. This is the original definition of the Pigou tax. If the amount of investment in any industry was carried exactly to the point at which the value of the marginal social net product there is equal to the central value of marginal social net products, the national dividend, so far as that industry is concerned, would be maximized, disregarding the possibility of multiple maximum positions. I propose for convenience to call the investment blah, 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 blah. Right? You can read this. This is the Pigou tax as proposed by Pigou. And indeed, what you see is that he proposes that there is a tax that would restore the social optimum. Actually, he pays more attention to the subsidy. In his time, that was called a bounty rather than a tax. That restores the social optimum. And that illustrates that Pigou was not thinking about negative externalities, definitely not thinking about environmental externalities. He was thinking about agglomeration effects rather than externalities. And that is why he puts the bounty before the tax, the subsidy before the tax. He was thinking of positive effects. Similarly, when James Mead started writing about externalities, he was thinking about the bees and their pollination. That was his prime example. It was a positive externality. Now, sometimes our students complain that we do maths, right? Read this, see whether you can digest it, and see whether you can truly understand what it says, right? This is how we used to teach economics back in the 19th century. I think my derivation is actually simpler and easier to understand than this. It's actually very exact language, but it's very hard to follow. Bit of confusion about the PQ tax. The PQ tax is sometimes called the polluter pays principle. That is wrong. The polluter pays principle simply says that that person or that company who had made the environmental mess should be paying to clean it up. Right? That is what the polluter pays principle says. It's a political principle, it's a moral principle, in some cases it's a legal principle. The PQ tax actually doesn't just say that the polluter pays, but it also says that the polluter pays a very specific amount, right? So the PQ tax is actually a good bit more specified than the polluter pays principle. The polluter pays principle also suggests that the polluter pays the victims of the pollution. But that is not in the PQ tax. What matters is that you pay for the negative externalities that you cause, and that corrects your behavior, you pollute less. That is how you restore efficiency. Then you pay, presumably, that tax to the government, and then the government can decide to give this money to the victims of pollution, or it can decide to put it in a Swiss bank account or buy tanks. But that is a political decision. Now, James Buchanan, who won the Nobel Prize, argued that in order to restore efficiency, the proceeds of a PQ tax should go to the victims of pollution. But William Baumol, who did not win the Nobel Prize, but should have, showed that this is really not the case. This is an issue of the second welfare theorem, right? You restored the economy to efficiency by implementing a PQ tax, and now the government is revenue, and that allows the government to, in principle, redistribute income, which you may think is a good thing or a bad thing or whatever, but that is a matter of the initial allocation of property rights, and you will get to a different Pareto optimum. What matters in order to get to a Pareto optimum is that the externality is internalized, not that you do something particular with the proceeds of that tax, right? And Buchanan was wrong about this. This used to be a question on the exam. It's no longer. It used to be that if you ask this question, Baumol and Buchanan disagree, who is right, and you pose that question to ChatGPT would say, oh, they both have a point, right? So that was an excellent exam question that tested not just your understanding of this, but also whether or not you cheated by using ChatGPT. DeepSeek gets this question right, so it's no longer an exam question, right? Okay, externalities. 20 minutes left to talk about public goods. So, what is a public good? Actually, the simplest way of explaining what is a public good is to start with a private good, which is not a public good. And a private good has two properties. One is it is excludable, and the other is that it's rivalrous. And my favorite example, because I'm not allowed to talk about beer and stuff, is to talk about ice cream. So if I have an ice cream and I eat it, you cannot eat it, right? Because it's no longer there. This is rivalry in consumption. If I eat it, you can't. So this is a physical property, right? Excludability is a legal or a moral property. If I have an ice cream, then it's my ice cream. And you can physically eat it, but that would be stealing, right? So you are not allowed, you may not eat it. Of course, after I have eaten it, you cannot eat it. Before I've eaten my ice cream, you may not eat it, right? So, this is a physical aspect, this is a legal or a moral aspect. And if we have stuff that is both rivalrous in consumption and excludable, then we call it a private good. If we have things that are neither excludable nor rivalrous, then we call it a public good, sometimes a pure public good. And an example is here, enjoying, I think this is an Arctic wilderness, right? Nobody really owns it, so you can go there if you want. It's so big, vast, so empty that if you go there, you won't. And I am there as well, but 3 kilometers away. We won't notice each other. We're not rivaling. We're not affecting each other's enjoyment, right? Similarly, if you have a lighthouse, any shipper who can see the light from a great distance is guided by this and benefits from it. And because it's just light there, you cannot say, but you are not allowed to look at it, right? That just doesn't work. So nobody is harmed by anybody else consuming it. You cannot exclude anybody from consuming it. That is a public good. Now, I call it a public good, a pure public good. It also immediately suggests that there are impure public goods. The one impure public good are so-called open access or commons. And they're called commons because every English village used to have a communal piece of land where any villager could graze their sheep or their goats or their pigs or their cattle, right? And if you lived in that village, you had an automatic right to put your sheep on the commons. You could not be excluded, right? So it's non-excludable. But of course, if my sheep eats the grass, your sheep cannot eat that grass. So it is rivalrous in consumption, right? But non-excludable. There's also goods that are excludable but non-rivalrous, and they are sometimes known as club goods, although the word club good means different things in different parts of economics. This is a concert. This, I think, 30 Seconds to Mars. This was a popular band among students when I put this up, but I don't think you guys have heard of them. It's excludable, right? If you don't have a ticket, you won't get into the venue. But it's non-rivalrous. I can go there and enjoy the music. You can go there and enjoy the music just as much, right? It's not that I'm blocking your enjoyment. Well, you may if you're tiny and I'm standing in front of you, but you see the point, right? So these are two impure public goods, pure private good, pure public good, right? The problem with public goods is that we take this one, my rational action is to put as many sheep on the commons as possible, right? Because that benefits me. It's my sheep. I get the wool, I get the milk, I get the meat. if my sheep eats a lot of grass and that causes soil erosion because of overgrazing, that is a problem that the costs of that are shared by everybody in the village, right? So the benefits of this activity are fully private. The costs are socialized, essentially. So everybody would put on more sheep than is wise, right? Here a similar problem emerges, that the owner of the venue has hired a band that is a fixed cost. So in order to maximize profit, you would let in more people than is really enjoyable, and again you would have overcrowding in the venue, right? So the problem with public goods is under provision, because you cannot exclude people and therefore you cannot recoup the full price of things. And there's overconsumption, and that is because the costs of using the good are shared by everybody else. Essentially you externalize the costs, and that leads to overconsumption. If you leave this to the free market, right? Of course, a social planner would count the total benefits and the total cost, and thus invest more or consumes less. We can make this more precise, and this goes back to Paul Samuelson. This is what he looked like at a very old age. I derived this. The product mix efficiency, the condition for product mix efficiency is the marginal rate of substitution equals the marginal rate of transformation. For a public good, the production is still governed by the same rules, the marginal rate of transformation. But what matters now is not the marginal rate of substitution, but the sum of the marginal rate of substitutions of everybody. And that can be done graphically. The book has different names, but the graph is the same. This is from Kolstad's book. And Kolstad lives in California, so he calls people Brewster, which he thinks is a proper name for a guy. Here we have quantity, there we have price. So we have two demand functions, Brewster's demand, Anna's demand. If this were a private good, then for the very first bit, Brewster would dominate Anna, right? So the demand curve would look like this. But then from this point on, where Anna actually has a positive demand for the good Q, C actually comes in, and then they're tussling. Here it goes to Anna, here it goes to Brewster, here it goes to Anna, here it goes to Brewster, and this is what the demand curve looks like. And that is because if Brewster buys it, Anna can't, and if Anna buys it, Brewster can't, right? So that is why we aggregate the two individual demand functions to the joint demand function like this. If it were a non-rival good, then they both can have it. So really at this particular point you would count the demand of both. Here you would count the demand of both. Here you would count the demand of both. So the joint demand function is Anna's function plus at the point where Brewster's demand also kicks in plus Brewster's demand function. So we call this horizontal aggregation. We call this vertical aggregation. This is what we do for a private good. This is what we do for a public good. Now, here the two are the same. The two are put in the graph together. So this is the demand function for a rival good. This is demand function for a non-rival good. And this is just an arbitrary supply function. And what you see is that the market equilibrium is different for the two, right? So that is the Samuelson condition for the provision of a public good. We can take that a step further and say, well, if the market indeed delivers this, we are in a Lindahl equilibrium after this guy here. And marginal rate of transformation is equal to the sum of the marginal rates of substitution, which can be seen as the willingness to pay, and we'll get back to the definition of willingness to pay. Willingness to pay is essentially a price, essentially the price you are willing to pay to get something. And what we have is that the marginal rate of transformation is not equal to the price of the good, the price you are willing to pay for the good, but it's actually equal to the sum of all our willingnesses to pay, all our individual prices. Normally in the market, we all have our, essentially our private bid for a good if it were an auction. And what matters is, in a private good, is whoever has the highest bid, and that sets the price. And essentially, the prices of those who did not win the auction are irrelevant, right? The marginal willingness to pay of everybody who did not win the auction is irrelevant for a private good, but for a public good, it's all our bids are added together for the auction. And that is because we're not auctioning something that only one of us can have, but because it's non-rival, it is the production, it is the willingness to pay, how much each of us is willing to pay, and we put it all together because we can all have it, right? Because it's non-rival. Now that is the Lindahl equilibrium. It's a wonderful theoretical concept, but of course we don't know everybody's individual willingness to pay for all the public goods, right? So it is highly impractical. So one more thing, and that is, how would the market provide a public good? So we have an economy with n agents in, and they're all the same. It's economics, right? We make it simple. And the utility function is essentially given by this. That is our total income, W, and G is how much we spent on a private good. And then we also have the consumption of a public good, capital G there. And the provision of the public good is how much the others provide, that is G bar, plus how much we provide ourselves. Because we're all identical, you can replace G bar with n minus 1 times G. Right? Now this is an indifference curve. What we have on the horizontal axis is the provision of, or how much you get of the private good. And what we have on the vertical axis is how much everybody else together provides for the public good. And our indifference curve looks something like this. It must look something like this. If the others do not provide much of the public goods, then it is in your self-interest to chip in, right? And we sort of like find the point how we act at where the indifference curve is minimal, where it essentially goes flat. And if it is indeed the case that it's rational to chip in with the provision of the public good, then the indifference curve must look something like this, right? It must start high, fall, and start rising again. Otherwise, we would not provide some of the public good out of the goodness of our own hearts, right? So that is an individual utility, or that is one indifference curve. Now, if the others start providing more, that is, we're moving higher up the vertical axis, then our utility goes up, right? Because there's more of the public good around. So U1 must be greater than U0, U2 greater than U1, and so on and so forth. And also, if the others provide more of the public good, then we need to provide less, right? And we can keep more of the money for our private consumption. So the minimum must shift to the, for you guys, left, right? And at this point, U4, the others provide so much of the public good that we don't bother and we just consume our own things. Come on. So this line here is the best response, right? It goes through the minimum of the indifference curves. That is the rational reaction to the provision of the public good by the other people in this particular economy. So that is what we would do. The social optimum. Okay. What I put in here, and that is where I used this term here, is this is the supply curve of the public good, right? I provide G, all you guys provide G, there's N of us, so this is the total supply of the public good, and that means that the slope of this curve is N minus 1, right? So it's fairly steep. So there's 2 points that pop up here, right? This is where the supply curve hits marginal utility. So this is the social optimum, where the two are parallel. But this is the market solution, right? The market solution is where the supply curve meets the demand curve, and the best response curve is the demand curve, right? So this is the social optimum, and this is the market equilibrium. So if we have a public good, even though all of us may chip in providing it, it is in all of our best interest to supply less, in our best individual interest, in the rational response, to provide less than what the social optimum would do, right? So under provision of the public good. Right? And the result is a loss of utility, right? Or if we move from the market equilibrium to the social optimum, because I said that U2 was greater than U1, we actually have an increase in welfare. So the big problem with public goods is under provision and overconsumption, right? So in the slides you will see an empirical example of this with fisheries of Argentina, but as we are out of time, I'm gonna leave that for you to study. I see you guys tomorrow, and Wednesday it's online. Don't forget, I'll send an email around to remind everybody. Okay, see you guys then.